after we recognize what kind of equation we have, we need to be able to write those equations. So we're going to start writing those equations from the word problems that we see here. Typically, when we write equations from word problems, I'm going to say 99% of the time, you're going to write a linear or an exponential function. Okay? So we're going to need to look for some keywords, and I'm going to underline those keywords as we read through these problems. So, Jim's customers must pay $50 for a membership plus $3 each time. This word for each lets me know that I have a linear function. So since I'm working with something linear, I know I have to fill in this y equals mx plus b format. For each, okay, I don't know how many times this person goes to the gym. So that for each is going to become my slope. Okay, so $3 each time. So I'm going to put in a 3. Okay. Jim's customers must pay $50 for a membership. Okay, so no matter how many times I go to the gym, I have to pay $50. My initial amount is always my y-intercept. So this is plus 50, and I've written an equation to represent this situation. Number 2, as a reward, you ask for a penny the first day and to double the amount each day for the first day. So we see this word doubles, and we should remember that doubles is the word that reminds us of exponential. So now I need to fill in a times b raised to the x. Okay? So as a reward, you ask for a penny the first day. Okay. So my starting amount is 1 penny. So that goes in my A spot. If this thing is doubling each day, okay, this word doubles is now my rate. Doubles carries a number 2 with it. Now we need our exponent. So we see this fancy word on the first day. So really this should be x minus 1 because we already got a penny on day 1. They were also nice enough to tell us our time. So if we want to completely write this exponential function, we would write y equals 1 penny. And I guess we need a decimal to represent that that's a penny, not a whole number 1. Okay. It doubles. And we're going to do 30 days minus 1 because something has already happened. It happened already. Number 3, Julia gets a prepaid cell phone. Initially, she has a $40 balance on the phone. Each minute of talking costs 15 cents. So we see this word each again. That tells me we have something linear. So we need to fill out y equals mx plus b. I'm getting charged 15 cents every minute. So this is my slope. But if I'm getting charged something, I'm losing money, so my slope is going to be negative. My balance is what I'm starting off with. I'm starting off with $40 for my phone. Number 4, at the start of a carnival you have 50 ride tickets. Each time you ride the roller coaster, you have to pay 6 tickets. Again, we see that word each time. Okay, so each time something is happening, so that's linear. So we need to fill out y equals mx plus b. So what is my initial amount? Let's start there. How many tickets am I starting off with? Did you answer me and say 50? You would be correct. So now I need to know my slope. How many tickets am I losing each time I get on a ride? 6. So since I have to pay those 6, I have a -6 out front. Last example, Miss Comb again spraying her garden with pesticide, and so every day there were half as many weeds as there were the day before. Initially there were 60 weeds in the garden. This word half, if I'm halving something, I'm multiplying by 1/2 every time. So I need the y equals a times b raised to the x function. What's my initial amount? How many weeds did I start off with? 60. How are these weeds changing over time? They're getting cut in half. And I don't know my time, so I'm just going to leave that as a variable x. Now those are from word problems. Let's take a minute and flip in our packet to find another example. This page is practice A on the top. So in practice A, we're going to scroll our eyes down to 6 and 7. And we're going to determine the best model. When it asks me for the best model, it's asking me to write a linear or exponential equation. Okay, very little is it asking quadratic. So we have to determine something. What is changing each time? Okay, so looking at our y values, how am I going from 45 cents to 90? From 90 to $1.35? We know it's going to be linear because I just calculated that we're adding 45 cents, okay, each time. Write the model that goes with it. Well, we know linear functions need a y equals and an x. My slope is I'm adding 45 cents each time. My y-intercept is my initial amount. Now, my initial amount is when x is equal to 0. If x equals 0, how much money am I paying? Or in other words, if I don't buy any apples, am I paying anything for them? The answer is no. So you could put a +0 or you could just leave it blank. If I ask you to predict the cost of apples in 8 years, you should substitute 8 in for x. And we get $3.60. Our last example for notes is this bottom chart here. Okay, so right now it looks like we are adding $1. But am I adding $1 here? No. So it's not linear. What about exponential? Remember, when we find a common ratio, we take our second term and we divide it by our first. So if I take 6 and divide it by 5, I get 1.2. Well, is 6 times 1.2 7.2? Yes. Is 7.2 times 1.2 8.64? The answer is yes. So we have an exponential model. So we're going to write y equals, and I'm going to have some parentheses raised to the x. What is my initial amount? What is my cost at year 0? It is $5. So that's the A value. And what's my rate? How big is this thing growing? We found it, it's 1.2. So if I want to know the cost of the game in year 7, I'm going to put a 7 in that X spot, and we're going to get $17.92. We're going to pick up with these worksheets at the start of class tomorrow. I would encourage you to try a couple more examples, and have a good night.